Okay. Now we're going to learn stoichiometry. Let me ask you guys, what is the term this word means? Stoichiometry. Yes, sir.
Basically, everything down to 1 atmosphere. So based off of 14.7 pounds per square inch. At least that's how I learned it in my other school.
Okay. Any other idea? What does this word mean? Yes, sir.
Whenever I hear stoichiometry, I think of quantities, but I don't know. Quantities.
Calculate the quantities from reactant to product. If that is the right actual answer. You said right too, but one thing, stoichiometry have to have chemical reaction. No chemical reaction, no stoichiometry. Yes?
So my school basically taught me, my technical school was basically, stoichiometry was the air-fuel ratio. So in the sense of how everything is programmed in cars, and how you read combustion levels, or whatever numbers you go off in stoichiometry, that's what it's taught me on. So.
Yeah, that's kind of, that's right though, because...
I mean, I see the difference, like obviously the reaction would be the air and the product would be the fuel. So.
Right, because the reaction going on there. That would be stoichiometry. So stoichiometry is, in a definition, is calculating reactant to product. One is known, other one is unknown. For instance, if you want to know how much product you can get from 10 gram of reactant. You have 10 gram of reactant, you want to know how much product you can produce. That is the stoichiometry that helps you to calculate how much you can produce. So if we simple write a reaction, so nitrogen plus hydrogen. So that producing ammonia. This ammonia, if I have 2 ammonia, I need 3 hydrogen to balance. So one more point came up. Stoichiometry have to be in a balanced chemical equation. You can calculate if you have a 5 gram ammonia started off, how much ammonia you can produce. That is called stoichiometry. Now you calculate. That means stoichiometry is a process or procedure to calculate from reactant to product. Or it could be another way. If you want to get 10 gram of ammonia you want to produce, you can calculate how much ammonia you need, or you can calculate how much hydrogen you need. You see, reactant to product. One is known, other one is unknown. This is a stoichiometric method. So the condition is you have to have a balanced chemical equation that have to be done before any sort of calculation. So how do you do that? The 3 steps I have here for you. A and B idea actually helps. A to B. For instance, problem number 1, I said 5 gram ammonia, 5 gram nitrogen can produce how much ammonia? So this is here as A, which is given. This is the B that you need to calculate, guys. So second problem, I said 10 gram of ammonia you want to produce. How much nitrogen you need? So here ammonia is A. The B is always the one you're trying to calculate. So let's see step 1. Step 1 is, you can see here, gram to mole. So you have the gram, you calculate from gram to mole, right? So this is A to A. Tell me, guys, how you calculate from gram to mole, if you have any idea. Multiply or divide?
Divide.
Yes, so dividing by molar mass, right? There you go. So then mole of A to mole of B. How do you get that?
Same divided
From the equation coefficient. For instance, you see, now this is a A, right? This is B. Coefficient of here is 1, here is a 2. So multiplying by coefficient. So multiplying by coefficient of B over coefficient of A. What is coefficient of B over A? Because A already got more. To multiply with the coefficient have to be B over A. So that A cancel out. This is because this is the A, right? This is the A. So cancel out, you have to multiply B over A. The finally mole B to gram of B. Tell me, how can you get mole to gram?
multiply
Multiply by what?
itself.
Molar mass.
Sorry.
Multiply by molar mass. You need that parts actually. This is various steps in mole concept, in the mole calculation part, right? So let's see the first one. First question was, how much ammonia will produce from 5 grams of nitrogen? You want me to write down the question?
Yeah.
Please.
Yes.
Thank you. So, question, you guys are awesome actually. How much ammonia will produce from 5 grams of nitrogen? See, this is the question, right? Now you can see which one is A, which one is B. Tell me why ammonia is B according to the formula. Because B is a unknown. Whatever the unknown, that's you consider the B. You need to know that part, how you follow the steps, otherwise it's going to be hard. Okay? The one is follow, the one is given A, unknown B. Okay? So step 1, I have a 5 gram of ammonia, right? Nitrogen. And to get to mole of A, which is mole of ammonia, then you dividing by molar mass of ammonia. Molar mass of ammonia is 28. So 28 gram of, molar mass of nitrogen, because nitrogen is A here. So molar mass of nitrogen, 28 gram of ammonia over 1 mole of nitrogen, right? Step 1. Step 2, you go to mole of A to mole of B. So mole of A to mole of B are so multiply by, so mole of nitrogen and mole of B is ammonia. How many mole of nitrogen is reacting in here to get 1 mole of? So this coefficient putting in front as a coefficient, and this is 2. So 2 mole of ammonia, right? And the last step is multiply. So you're writing 1 mole of ammonia in the bottom, and the top would be, so ammonia is a 14. So 14 gram of ammonia. So you always calculate molar mass of ammonia. Nitrogen is so 28, and for ammonia molar mass equal to nitrogen is a 14 plus 1 times 3, which is 17. So this is actually 17. 17. So go back to review what we did. We put it A, what is given. We divided by molar mass for nitrogen 28. and molar mass of nitrogen 28. How did you get it? 1 nitrogen is 14. You see the periodic table? Nitrogen is 14.00. So 14 times 2, 28, right? So 14 times 2 is 28 gram, right? And then you put 28, converting gram to mole. Why put a gram in the bottom? So in the denominator because need to cancel out. Gram can cancel out, and numerator would be the mole. And you put a mole of nitrogen to cross position as a denominator to cancel out mole of B, which is ammonia. Again, mole of B in the denominator to cancel it out, because you want to get gram of B, which is gram of ammonia. That is the question asking, how much ammonia, which is B. So gram on the top, numerator, to calculate that. So let me erase that part. So to calculate, you have a 5 in the top, 5 times 2 times 17. In the bottom you have 28 times 1. So now you can calculate that. So 5 times 2 times 17 divide 28. So 6.07. So 6.07. So how many sig figure we have? Sig figure is 1 sig figure, because 5, only 1. So that will be 6 gram of ammonia you can expect. So that means the answer is, if I have 5 gram nitrogen, I can expect that 6 gram ammonia will produce. Can you solve the second one in a group? Second question is, here, question is, how much hydrogen needed to produce 10.0 gram of ammonia. Okay? How much hydrogen needed to produce 10 gram of ammonia? Please work in a group, even though our classrooms are kind of, separated. So still you can talk to each other, work in a group. Yes, ma'am?
The 2 moles, did you get it from that there?
Yeah. To get as a prefix, yes, ma'am.
So
coefficient come in, as prefix come in, then coefficient. You see, coefficient. I mean, yeah, that's a prefix.
So it goes grams of what you know to moles of what you know to grams of what you want to moles of what you want. That's how it goes.
Yes.
So grams of what you know.
Basically, following step 1. Mole of A, mole of B, gram of B.
Yeah.
Keep the coefficient when we're doing it.
That's how you know what it goes.
Keep the coefficient here, yeah.
Okay.
What's your question? What's your question?
Yeah, that was my question.
Okay. Yes, coefficient you multiply.
See this one?
Please walk in a group, please.
You gonna get what you know.
Oh, you can move
So
some
moles
more.
of what you know.
Go there. Be good friend.
Moles of what you
Try
want.
to know this.
You want. I've lost them. Make the product. This is what you want.
Grams per mole.
So you want to. So moles of what you want. So grams of what you want. This is the mole amount. This is what you want. 2 moles of this. So basically what is the difference? The outcome? Yeah. So you take my trial, you have it. Okay. So what's grams of what you want? To moles of what you want. To moles of what you want.
Okay, please walk in a group, please. She's taking it, but she said no. She has some.
First to find the correct mold, and then that's a mold.
Oh, you good? He doesn't think you are. But he don't even look at you.
Oh, I didn't. Sorry.
This product is given so how many so let's see.